So today we're going to take a look at the nth term test, which is actually just a divergence test. We cannot show convergence with the nth term test, but this is a kind of a useful tool to be able to quickly assess whether something's just simply divergent. So a lot of times on the AP, you guys might be given like 2 or 3 series in one question, and they'll ask you which of these series are convergent. So we could quickly rule things out if we run through the nth term test. So kind of keeping that in mind, understanding the only condition that can be met is that of divergence, showing that the limit does not equal 0. So really, again, limit being anything other than 0, this will show a condition of divergence. Otherwise, it's inconclusive. We cannot say. So just kind of taking a quick look at the practice question here. One thing we can do to use that nth term test is we can evaluate the limit as n approaches infinity of the series. Now remember, the series is the function, right? It's the equation next to the sigma notation. So as n approaches infinity, we want to see what is the limit of 3n cubed plus 1 over 5n cubed minus 2n squared plus 1. And the cool thing about this is it kind of helps us review those old limit rules. Since this is equal degreed in the top and bottom, the highest exponents are n to the thirds, we can look at those coefficients and we can say, hey, look, this limit is 3/5. So since that is not 0, we can say that this series diverges. All right, we could look at this next one too, kind of do that same thing. We're going to evaluate the limit of the sequence. So the limit of n approaching infinity of 3 times 1/2 to the nth power. Now this one's kind of interesting because 1/2 to the nth power, as we raise that exponent larger and larger, that denominator is getting larger and larger, but the numerator is staying the same. So this is essentially going to approach 0, and 3 times 0 gets us 0. So what that means for us is that this test is inconclusive for the nth term test, and what we would need to do is use a different test to try and test for convergence. Now, this one specifically, since we have something to the nth power, is a good opportunity for us to use a geometric series test. So I'm going to continue with this, and I'm going to say, okay, well, now I'll test a geometric. Right, so in this case, this looks geometric. I'm identifying the r is 1/2, and since the absolute value of r is less than 1, I know that the series converges. Now, it doesn't converge because of the nth term test, but it converges because of the geometric series test. So just something for us to kind of keep in mind with these. So give this a little practice. Let me know what you guys think, and we'll keep on moving.